This is lhendupjadoo from Engineers of Himalaya. Let us design G+2 RCC residential building using Staad Pro Select Series 6. First of all, let us assume the building properties. Let the height be 9 meter, width 12 meter and length be 15 meter. You can see from the plan there are 3 number of bays along the length and along the width, and lengths are 444 and 555 meter. Let the column size be 0.4 by 0.4 and beam size be 0.3 by 0.4. Concrete strength be M20 and steel strength be Fe500. Now before proceeding with the design, we have to check the irregular, whether the building is irregular or regular. For that we can find out in IS 1893-2002 part 1. So if the building is irregular, we have to proceed with dynamic analysis, and if the building is regular, then we can proceed with static analysis. Since our building is regular, so we can proceed with static analysis. For that we will go to new project, space, give your file name, file destination by clicking on this 3 dot. Unit length is meter, force is kilonewton. Next, yes, you can proceed with add beam also. In our case we will proceed with open structure result. Truss frame model, bay frame, length is 15 meter, height is 9 meter, width is 12 meter, along the length bay is 3 meter, number floor 3 meter, and base along width is 3 meter. Now 333 meter is our height and 444 is along the width. Apply, file, merge with Staad Pro, yes, okay. Now if we click on this rendered view, we can see the line diagram, which means that no property has been assigned. So let us assign the property. Prismatic, rectangular, concrete, 0.4 by 0.4 at ZD for beam is 0.3 at, bring it here, column, select, beam parallels to y-axis, assign to selected beam, and beam parallel this one, select by missing attributes, missing properties, yes. Now if we click on the 3D rendered view, we can see that all the properties has been assigned. But if we look very closely, we can see that the beam starts from the center line of column, which actually has to start from the column face. So let us rectify this. To rectify this, go to general, specification. Before we proceed with this, we have to first know what is global axis and local axis. Global axis is the overall axis of the Staad, which we can see on the Staad window at the lower left corner. And for the local axis, individual member has the axis, which we can see from the symbols here, and labels, beam orientation, apply. So here we can see the individual axis of a beam or column. The blue is x-axis, green is z-axis, and red is y-axis. So we have to apply, we have to make changes in the blue axis, which is x-axis. So apply, okay, close. Now what we will do is we will offset, start global, local, change it to local direction, 0.2 at beam, offset, and local minus 0.2 at, okay. Now the column we will leave as it is, and only we will modify the only beams. Okay, assign to selected beams, choose another one, assign to selected beams. Now if we see from the top view, you can see that the beam has been changed. So view selected object only, again click once, and now if we click on the rendered view, all the beams start from the column face. So next we have to proceed with the support command. Support specification fixed, add support, change this view, assign. Support has been assigned. Now the last thing is we have to proceed with loading, and firstly we have to define load. Loading definition: Seismic IS 1893-2002, IS 1893-2002. Generate zone. Since we are designing a building in Bhutan, so let it be zone 5. Special RC moment resisting frame, all building, medium soil, RC frame, damping ratio. If you refer IS 1893-2002, IS 1893-2002 clause 7821, damping ratio of RC building is 5% for critical. So we will in 5% damping ratio, 1.5 foundation, and period in X. And as per IS 1893-2002, the natural time period can be found using this formula for without brick infill and with brick infill. Since ours is with brick infill, we have already found that natural time period along X is 0.209 and 0.234 second along Y. 0.209 and 0.234. Generate 0.05 at. Now we have defined the earthquake. Now what we have to do is we have to add the earthquake weights, seismic weights. To do that, firstly we have to understand this. As per IS 1892-2002 743 clause, the weight between the story shall be distributed to the story above and below proportionately according to the distance from the floors. So which means that this wall will contribute half of its length to the floor above, and this wall will contribute half of its length to the floor below. So if we consider the member width, external wall load shall be 0.25 thickness, 3 meter height, and unit weight of brick plus portion of PCC plaster is 20 kN per meter cube, which comes to around 15 kN per meter cube. So this shows that the weight contribution is from half is from below and half is from above. And similarly, the other floor 15 kN is done, and for the roof only a half length of the wall will be contributed to the roof floor, which will come to around 7.5. Similarly, for internal wall loads on the floor shall be 9, and the effect of internal wall load on the roof shall be 4.5 meter. Calculation you can see from here. 0.15 is the thickness of the wall, and floor weight RCC slab shall be 0.15 thickness, 25 kN per meter cube. Unit weight of RCC and 3.75 kN per meter square is the floor weight. You can notice here that there is no direction, since we will assign the direction later on. So impose live load. As per IS 875 Part 2, residential building, all rooms shall be 2 kN per meter square, and you can refer other type of building and other rooms from this one. For now we will consider 2. Impose load for earthquake. As per IS 1893-2002 clause 731, percentage of imposed load. if the imposed load is below 3 or 3, we shall consider only 25% of the imposed load. If it is above 3, we shall consider 50% of the above load. IS 1893-2002. As per IS 1893-2002, 25%, or in our case it's like below 3, so we will take only 25% of 2, which is 0.5 kN per meter square. Okay, so now we will proceed with it. Self weight, we have to add member weights. We have already found out member weights: 15, 7.5, 9, 4.5. 15, 7.5, 9, 4.5. Now floor rate is 4. Floor rate 3.75. We shall consider only for these two floors, ground floor and first floor, since on the roof we don't we assume that there is no slab. So 3.75. Save, yes. Y is 3, height is 3, height is at 6, and height is at 9. So to include these two floors, we will consider our range from 2 to 7, which will count this from here to here. So minimum is 2 and maximum is 7. Add. Again, for the live load, our live load is 0.5. Contribution from the live load is 0.5 kN per meter square. So contribution from the live load is 0.5. Limits will be same range. Okay. Close. Okay. Now contribution from walls: 15 and 9 is also contribution from internal partition walls. So selected beam, assign on the floors. Now this is 7.5 is contribution from external wall on the roof. So select only roof. View selected, top view, 7.5, assign selected view, 4.5, assign selected beams, assign. Okay, now all the member weights and seismic weight has been assigned. Now what we have to do is we have to proceed with the other loads. Okay, now go to command loading, primary load. Since we have just assigned and we haven't given any direction, so we will give this direction to seismic weights. Seismic, choose load type seismic, EQX, add EQZ, add dead load, add dead load, add live load, add. Okay, now EQX, add seismic loads, X direction, add Z, add seismic Z direction, add factor is on, dead load, add self weight. So now you will see the dead loads. In dead load we have a contribution from external wall, internal wall, floor load, roof load, and any other permanent load. For imposed load, we have to refer IS 875 part 2, and seismic load we have already considered. So now for dead load, our member load is external wall 0.25 thickness, 3 meter height, and 20 is the unit weight of brick and plaster, which comes to negative 15 kN per meter. We have assigned negative 15 because our global axis direction y direction is upward, and our load direction should be downward. That's why it's negative. So similarly, we have internal wall is negative 9. Floor load, we have thickness is 0.15, unit weight is 25, and 3.75 kN per meter square. Imposed load, we have from IS 875 part 2, all room is 2. So now let us do 15, 9, 3.75. 15, 9 member load minus 15 at minus 9, direction is global y-axis, at, and floor load minus 3.75. range is again same. From this, we consider this 2 floor, 2 to 6 and 3 to 6 now, so we should consider 2 to 7. Y range is minimum is 2, maximum is 7. CFS maximum 7. Add and close. Now live load. Add live load, we have 2 minus 2. So live load, floor load minus 2 to 7, range same. Okay, now let's assign to view, celebrate external load. For external wall, we consider only these two, since the wall will be falling on these 2 floors. Top view, select, assign to selected beam, 9, internal wall, selected. Okay, now now we will do load combination. We can do automatic load combination from here, but what we will do is we will create our own load combination. We have to do this only for once, and then we can use that later on. So to do that, you have to go edit load rules. Okay, new code is LIMI Limi Bhutan. Let it be Limi Bhutan. Code name is done, and category, new category should be BHUTAN Bhutan. Number of rules, let it be right now is 5. Add. Okay, now what we can do is we can refer as 1893 2002 clause 6321 load combination for limit state design, 1.5 dead load and plus live load. 1.5 dead load, 1.5 live load, and next 1.2 dead load, live load, earthquake plus minus. 1.2 dead load, live load, seismic. 1.2 minus 1.2, and 1.5 dead load plus minus earthquake. 1.5 dead load minus 1.5, 1.5, 1.5, 1.5. Okay, this is done. I can add new row. This one is done. 0.9 dead load plus minus 1.5 earthquake load, 0.9 dead load, 1.5 minus 1.5 minus 1.5 earthquake, 0.9 dead load, 1.5 plus 1.5. This is done. So rule is 1 2 3 4 5 6 7 rules. Now update table. It is done. Now we have our own load combination. So go to now loading, automatic load combination. We have Limi Bhutan here. Choose our load combination. Bhutan, generate load, add, close, and now command analysis, perform analysis, all okay. Go to analysis, run analysis, save. Okay, now analysis part is done. Now let us proceed with design. Command design, concrete design, IS456, define parameters, FC is 20, 1, 2, 3, add FY main 500, 1, 2, 3, add FY section 500, 1, 2, 3, add. If you don't assign the other properties, it will be the default value, so let it be right now. Now design column, add, go to here, 20, assign to view, assign to view, assign to view. Let us design only the ground floor column. So select the ground floor column only and select this one and assign to selected. Now command analysis, perform analysis, or analyze, yes. Okay, let's view the output file. From the output file, we can see for example, for column number 10, if we check for which is column number 10, select this one, view only, shift B, column number 10 is this. For this one we have 1280 square meter. So our required steel is 1280 square meter. We can provide 8 numbers to 16 die, which has the area of 1608 SQM. For detailing, you have to refer 139 IS 13920-993 and SP34, which is very important. You have to refer it, and IS 2502 also you can refer for some detailing. So basically that's all about design. Now you can what you can do is shift B, view. Now what you can do is you can go to post processing, apply, okay, and reactions. This reactions, what you can do is you can copy all the reactions, Control C, go to Excel file, EX, go to Excel file, Control V, so here fx fy is second one, fy is second one. Delete this one, delete. Okay, now select from here and sort from largest to smallest. So delete all that one, delete. Like this you can do for node. This is for node 1, node 2 you can do. Node 1 maximum is 410. So like this, like if you want to check our nodes, which from top view, select the node cursor, view only, top view, shift N. So like this we have for this case we have node number 1 is 408. So node number 1, this is 408 kN. So to design footing, we have to take this loading, take 410.8. So we can what we can do is we can now proceed with footing design in